Hello everyone, welcome back in the course of higher surveying, and we are in the lecture 2 of module 9. Okay, in the last lecture of the hydrographic survey, we have learned that what is the importance of the tide. Okay, first of all we learned that why should we measure the 3D coordinates of the terrain which is under the water, right? And that is what we said, that hydrographic survey is very important for many reasons. Okay. Now, we then learn that the depth of the water, which is the height of the water above the river bed or sea bed, varies with time because of the tides, and tides are created by the combined effect of sun and moon gravitation. Okay. There, when we see that the height of the tide is basically decided by the moon's gravity field and the earth gravity field, and when they are in balanced state, when the gravity of the earth and the gravity force of the moon both are under equilibrium, then that equilibrium point decides the height of the tide. Okay. So, then we see that why the variation in the tides occur as the movement of the moon is around the earth changes. Fine. Then we have realized what is the frequency of the tides. It could be daily, it could be fortnightly, it could be monthly, or it could be annually, semi-annually, and it could be at the interval of 19 years. So, different aspects we have learned about the recurrence of the tides. Okay. Then we looked into the terms like spring tide and the neap tide. Fine. I hope that you are able to recall all this thing. Later, we have decided that later we have discussed very briefly that how to establish the horizontal and vertical control for the hydrographic survey. Okay. Later on, we see that once we collect the 3D data using sounding operations and the planimetric position methods, we will be preparing the two products. One is nautical chart and another is hypsometric curve. Okay. So, that is what we have discussed in our last lecture. Okay. In this lecture, we are going to talk about how to perform the survey or how to collect the 3D information of the riverbed or seabed in the given situation. Okay. The most important aspect here is we first of all separate two surveys. One is vertical survey and other is horizontal survey, or I should say that horizontal positioning and vertical positioning are separated because we know that depth of the water or the vertical position of a point which is below the water level is to be measured by some instrument that can penetrate through the water. It could be a mechanical instrument like sounding pole or a lead line, right, or it could be some kind of acoustic instrument like echo sounder. So, that is the vertical positioning. On the other hand, if we talk about the horizontal positioning is obtained with the help of conventional surveying method or maybe modern methods. However, the observations are to be taken on the surface of the water. Well, so we see that okay, this is the location xy on which I will take the sounding. So, xy location has to be known in order to make the sounding position, the measurement of the sounding very relevant. Fine. So, in this lecture we are going to discuss mainly about the horizontal positioning methods. Okay. And these methods are decided by the given situation or the circumstances at the field site. Fine. So, let us dive into the lecture. So, this is our second lecture, what we call them, what we name it as a field procedures for hydrographic surveying. Okay. So, these are the books. And now, before we start this lecture, let us first look into the simple terms. You might have used three terms like beach, coast and shore or shoreline many a times. Okay. So, what is the difference? And is the difference important for us? In fact, yes. When we use these terms technically, especially in the context of hydrographic survey, we should be very careful. Okay, let me first define what is beach. Okay, many of the times we go to the beach to enjoy, for the purpose of recreation. So, the beach consists of the unconsolidated material. Fine. As shown in the figure here, this is the kind of unconsolidated material lying over there, right? It could be sand, it could be rocks, it could be pebbles, it could be gravel, whatever, fine. But it is unconsolidated, which means the water can penetrate through it. That means the voids between these particles are not filled by the water, rather it is filled by the air. So, any part of the place near to the sea which is like that, we should call it beach. Okay. What about the coast? Coast is just like a reference line which is permanent in nature. That means it could be a firm line created by the rocks, natural rocks, or it could be a firm line created by the artificial structure. But it is permanent in nature. It cannot be changed by the movement of the water. That means water cannot cover it, or water cannot change it, or water cannot displace it. Fine. So, I hope that you are very clear about what is coast. And secondly, when we use the term coastline, that means the line created by the coast. It is called coastline. Or sometimes you might have heard the word Coast Guard. So, Coast Guard, they stay on the coast. Okay. Now, last term is there, that is called shore. What is the shore or shoreline? Okay. If you see the movement of the water, what will happen? Water try to reach to the land and try to disturb some of the features on the land surface. For example, it try to first of all disturb the available sand, right? It try to changes the island shapes. Shore is the wider fringe of the land that is geologically modified. That means if there are some small rocks, they are moved or again they are brought back by the water. And that is why the line which is created by such a phenomena is called shoreline. So, shoreline is not a kind of fixed thing, it is a kind of time changing phenomena, or rather at a certain time it is visible in certain position, maybe it will be changing with time. So, after few days, few hours, few months, if you come, that will change. And so, all the rocks which are affected by water geologically, we call them, it is a part of the shoreline. I hope you got the idea what is shore, what is coast, and what is the beach. So, now let us go forward in the lecture. Okay, the horizontal control we have defined last time also, and again we are redefining it. It collects and coordinates the horizontal position data. That means it will collect the xy position, as well as it will ensure that if this is the x1 y1, it is x2 y2, this is x3 y3, they should be in coordination to each other, right? That means if they are in same reference frame, they should talk to each other, they should have some relationship between each other, and that relationship should represent the correct topographic information of the riverbed or seabed. Okay. It should be precise and it should be accurate. Okay. Then what are the general rules we should follow? The first rule is, if the width of the water body is more than 1 kilometer, okay, so in that case what should you do? Okay, let us say there are two shorelines on one bank and another bank. So, there are two banks and we have two shorelines, and the overall width of the water body is more than 1 kilometer. Fine. So, what do we recommend? That we should conduct the survey from both the sides. That means we should draw the lines from both the sides, and we try to conduct the survey. Further, we say that use some common tie lines and connect both of these survey, right? What will happen? The check lines or tie lines will ensure that the quality of the data in both portions are of same nature, and that is the reason the two data can talk to each other, or two data can be synthesized in a one data form, and then we get the complete data set of the water body. That is the idea here. But what about my water lake or the water body is the width of the water body is less than 1 kilometer? Okay. In that case, we recommend that start your survey, the horizontal positioning basically from one shoreline only. One more thing here, if shoreline filled by the vegetation, then triangulation system should be adopted. At the same time, if large network of triangulation system for large lake and ocean shorelines should be adopted. Fine. Now, let us start with the horizontal positioning methods. The first method is, so we have categorized those methods into different categories, or we have classified them. Okay. This classification is not available in the books, but based on our understanding we have done it. So, First is the method of direct observations. That means we are observing the point xy by direct observation. It could be an angle measurement, it could be a coordinate measurement, it could be a distance measurement. That means we are not deriving it by some calculation. Rather, we are saying that, okay, let us make this position in maybe polar coordinate system or Cartesian coordinate system, but measure it directly, and then we can later on derive some information. But our observations are very, very direct at the point. So, first method is parallel line method, then we talk about ray method, then we talk about location by cross rope, then location by range and one angle from shore, and location by range and one angle from boat. Then we will talk about resection method, intersection method, and combination of resection and intersection method. Further, we will talk about location using intersecting ranges, then we talk about tachyometric observations, then EPS method, and finally the DGPS method, or differential global positioning method, or differential GPS method. So, let us start with our direct observations. So, this is our first direct method where we observe the position of the sounding location by direct observation. That means we are observing maybe angle or distance, but we are observing it directly from an instrument and we are recording it. So, let us look into this method, and this method is parallel line method. Okay. In the parallel line method, you can see there is a shoreline and there is some line which is appearing as a horizon to me. That means it could be another bank of the river or water body. Fine. So, now we first lay down a reference line on the shoreline, and these are my reference marks shown in the screen. Okay. Then this distance between the two reference mark is divided into equal intervals like this. Fine. So, after dividing into the equal interval, let us mark these points here like this. Okay. On this point we will put now on this point we want to establish the perpendicular lines or the survey lines or our range lines, right. So, what do we do? What do we do here? We take an optical square like this and we put on these points one by one, and using the optical square we draw the survey line or the range lines which are perpendicular to the reference line. So, this is my first survey line, okay, which is in transverse direction to the reference line. Now, what do we do here? Basically, we stretch a float line. Float line, let me tell you about float line. So, what do we do here? We basically take the float line, and one end of the float line is tied at the reference mark. Remember, we have marked 3 reference on the screen. So, one of the reference mark where I am putting this optical square. So, there itself we make a peg, or we make some kind of knot here, and with the help of some nail, and with the help of this nail, what do? We take the float line which is shown here in the screen, which is a kind of graduated line, right, and it is having buoys. So, what do we do here? We take a float line which is shown here in the screen, and we stretch between the reference mark that we have already marked on the shoreline on the reference line, and we stretch it across the river. Okay. There, since the length is almost 200 meters, so we can cover up to the 200 meter length, right. Now, what happens here? This float line is having the buoys, what you call here, or they are floating bodies. That is why this float line always remain on the surface of the water, even it is visible also very clearly. Since these buoys are marked, or these tags are marked at a regular interval, so this float line is my graduated float line. That means I know what is the distance between these two tags. Okay. Now, what happens is since we have stretched this float line across the river, and now we are moving from one end to another end. That means from the shoreline to the next end in the river or water body. Okay. So, at this location where buoys are there, since it is stretched in a straight line, so I am measuring the distance x with the, let us say, the x distance or maybe the y coordinate on the graduated float line, and I already have along the one distance called x or maybe y, whatever. So, you can have, if you call the range or the distance along the float line as y, then you can call the distance along the reference line as x, right. So, I will show you what does it mean. Fine. So, after that what you do, you move your boat along this float line, and at each and every tag point you will take the sounding observation. Well, the sounding observation can be taken with the help of echo sounder, or with the help of sounding lead line, or with the help of sounding pole, or with the help of sounding pole. Well, so all three methods are possible with us. However, since if depth of the water body is less, we would prefer sounding pole. If depth is little more than, let us say 8 meters or 6 meters, we would prefer to have the lead line. Okay, I hope you got the idea. Or if depth is still more, what do? We will take the echo sounder. So, it depends, the choice of the instrument depends on us for the sounding. So, for the sounding purpose, the choice of the instrument depends on us, right, and the depth of the available water body. Fine. So, if you see here that there are three type of material are there available: nylon, polyethylene and polypropylene. Most appropriate is polypropylene here. You can see that the total weight of the 200-meter line is only 15 kg or close to 15 kg. So, it is most suitable. So, it is very lightweight basically. Fine. So, now we have seen that this is the point. So, this is my distance x here from here to here, or I can call it x1. So, now I will measure my y along float line, right. So, let us see, this is the situation here. At 5 meter I will take my sounding, and that at 10 meter I will again take my sounding observation, and so on. I repeat this process like this along the line. So, I am taking the observations here, next observation at 15 meter, and next observation of sounding at 20 meter, at 25 meter, and so on. I keep on repeating this observation. Well, so once this line is finished, or I completed this line, then this boat will be turned onto the next line like this. And so, we will come back and we will observe these points also. That means, we are observing the sounding at these points also, every point. And now, we will repeat this process for the rest of the survey line or range lines. Fine. So, that is the process in the parallel line method. That means, we have divided the whole area of interest or the river body into parallel lines, and we are observing the sounding readings as well as xy position, right, at regular interval. So, I am getting a very nice grid of data x, y, z. So, each point is representing my x, y and z. X and y are measured. X is measured on the reference line. Let us say y is measured along the float line, and z is measured using some sounding instrument. Fine. So, that is the kind of mechanism we always follow in each and every data measurement. That means, how to measure x, y. So, measurement of x, y could be different techniques. However, when we measure the z, we have the one sounding instrument with us. Fine. Okay. So, now if you see this run, when boat comes from the offshore to inshore or towards the shoreline, it is called inbound run, like this. Similarly, when boat goes away from the shoreline towards the offshore, we call it outbound run, like this. Fine. I hope you got the idea. So, we will repeat this alternate outbound run and inbound run to cover the whole area of interest. So, like this, we will collect data on these points. Now, you can understand very easily that we are developing the data x, y, z. We are observing, we are taking the measurements x, y, z at each and every tag of the float line, or maybe we have pre-decided that what should be the distance, right. So, this is x1 is nothing but my line spacing, and you can see here that we have assumed that we have done this job at very regular interval. That means, my line spacing is very regular, and my points are also placed very regularly. So, I am getting a rectangular grid. Here you can imagine what are the assumptions we are making. We are making one assumption that there is no wind current. That is why it is very easy to stretch the straight float line. Also, the float line is stretched with the help of sometimes other boat, or if river body is very small, we stretch the float line with the help of some other anchor on the other bank. So, there are two methods possible. Fine. So, that means one boat is stretching and another boat is moving in order to take the observations. So, that is a method what we call parallel line method. Okay. First of all, since the float line is straight and it is not moving, which means there is no wind current and there is no water current. That means the body, water body is very calm, very stable, right? Okay, I hope this you got the idea here. What's the meaning here, right? And by this we can collect very dense data in minimum time. So this method is very efficient under given circumstances where there is no wind current and there is no velocity current or the water current. So now you can see that handheld optical square used, and then the maximum allowed distance is 200 meters. That means the length of the float line is 200 meters. So if I stretch one float line, so that is the maximum length we permit in case of parallel line method. Okay, what is the reason? The reason is that I want to collect some data which is very, very dense at very regular interval near to the shoreline and not away from that. And secondly, the assumptions of low water current and the no wind velocity is appropriate there, right? And that is why this method is very much restricted up to 200 meter only from the shoreline, or I can say from some jetty or so on. Okay, so it is only suitable for the fishing landing areas, small fishing ports, some breakwater construction, and minor reclamation and minor excavation or small dredging purposes, right? And perfectly calm sea is required. I think I have repeated all the things again for you. Fine. Now let us look into the ray method. There is another method, right? Let us, in case of parallel line method, I assume that there is a long shoreline and we are stretching one reference line between two reference mark. Now imagine that it is not possible to establish another reference mark. That is only possible to establish one reference mark. Why? Because there could be any reasons. That means depending on the field situation, sometimes there is no place to establish the reference mark, or there is no way to refer the reference mark with our topographic survey. So in order to connect my hydrographic survey with topographic survey, I need to have some control stations which are well visible to me. And let us say there is only one station is possible to use, and this location is this one. So what will I do now in this case? And let us say this is the area which is accessible by a surveyor, right? This is the kind of land area. Now at this point, let us say this is the point where he will establish his total station or theodolite. Okay, then he will orient his theodolite or total station towards this line. That means it's 0 degree, 0 minute, 0 second line, or it's my 0 reference line. Now I will spread a line here, and this is my shoreline here, right? So you can see here we will stretch one survey line here like this, and let us say this angle is my A degree. Fine. Then what we'll do, again we will observe the point like this at a regular interval, and we will measure the sounding like this, right? And again we will come back to the same position, back to this point. Okay. Now you can observe here that we have observed few points here, fine, and they are also at regular interval. Okay. Now we have collected at least couple of points along a ray line, and that is why it is called ray method. Okay, what is next? We will spread, or we will understand another ray line at A plus 5 degrees. That means we have doing some increment by 5 degrees. Okay. Now again we will repeat the same process like this. Okay, and so we collect these points. Okay, what is next? We will come back, and then next time we will have 5 degree increment like this, and again we will collect these points. Fine. So now you can understand how easy the ray method is, where there is only one surveyor is controlling the complete survey. Fine. Again, this line, for example, any ray line can be stretched with the help of float line, or even we can use their total station or theodolite to measure these distances. But the issue here is, since we are measuring these points at a regular interval, I need to have some device which can provide me the data at regular interval, and that is why the float line is the best solution here. So spread the float line maybe with the help of some anchor on other bank, or with the help of a boat, another boat. So another boat is stretching the float line, and at one end on this point it is anchored at this point here, and then boats are moving. Fine. So now you are measuring the xy position with the help of float line, and you are at every such a point where you are observing xy, you are also measuring the sounding position or the sounding measurement. Fine. I think this is the very standard method. Now I can use any instrument for sounding, but we always do it, right? So that is why we say it is not a pseudo 3D survey. It is a perfect 3D survey where we are measuring x and y position and we are measuring the sounding position. Fine. So 3D data is collected always simultaneously, although we have separated the vertical and horizontal survey here, but still we are measuring the 3 data simultaneously. Fine. So now in the coming slides, whenever we make this dot here saying that we are taking measurement, it means we are taking all 3 measurements x, y and z. Fine. So that is my ray method, which is another direct method because we are observing the distance as well as the angle. So let us say at a degree angle, I have observed 1, 2, 3, 4 points here, right. So I know the distance along this ray, what are the regular distances of these points. So I can now make the map and mark those points. Ray method here, the maximum offshore distance is 3 meter, or in case of triangulation, it is 1000 meter. Here in case of ray method, that acceptable accuracies are obtained. Okay, fine. So as I already discussed, it is preferred when the fixed points are inaccessible. That means only one fixed point is accessible, and so we are using some kind of small land area, and now we are doing it. Then we do the ray method. Okay, there is a third direct method. It's called location by cross rope. Okay, what is this cross rope? Let us say that water body is very small, 8 meter, 10 meter, 20 meter, something like that. So across this water body, we can stretch a rope, okay, and which is also graduated rope. That means it's like a float line, although float line is needed when we want our reference line or our range line or our survey line to float over the water. So right now the requirement is not like that. Fine. Now we are stretching the rope, and this is my water level here. Fine. So boat is there also, right? Okay, so we have stretched our, let's say, float line across to this point and this point. Fine. Now what to do next? Okay, along this float line or the rope, we will take the observations like this at a regular interval, like this. So you can see here that we are measuring the xy position for each point here. At the same time, we are taking the z by sounding. So now we repeat for the whole of these points, right. So my boat will be definitely reaching here, and again we will take another section and we will repeat this thing. Okay. So it is the most accurate method for dredging work. Suppose there is a dredging, that means we want to do some kind of dredging or we want to deepen our channel. So we should use this location by cross rope method. Okay. So width of the water body is very small here. Fine. For the small rivers and we can say the small channels, we should use this method. That means if we can stretch a straight float line, a straight rope across the 2 banks, then and then we should use this method. But since it is most accurate, it is always welcome. So for narrow lakes, small rivers, we use this method. Okay. Now again, in case of ray method as well as cross rope method as well as parallel line method, you can see we have assumed that my rope either along the any survey line, whether it's a kind of diagonal survey line or the inclined survey line in case of ray method, or straight survey line or range line in case of cross rope method or parallel line method. They are very much stable, which means there is no wind current and there is no water current is there. That means water is very stagnant or very still, very calm. So in that case only we use these 3 methods. Okay, let us say direct method 4. Fine. Let us assume a situation where I have a point B which is available on shoreline and we have another point A1 or right. So what I plan now, I plan to acquire the data along this line which is marked here. Fine. So boat will be moving along this line and it will be collecting the data at certain points. Fine. Okay. And then we will be measuring the angle of the boat or boat as a target and we will be measuring the angle from point number B, right. So, let us see into the animation, what does it mean. So, let us say at point A1 we have a flag, that means we have established a flag, that is a kind of reference mark, and again in order to align the line, this line, our outbound turn, we have marked A1 and A2. So, A1 and A2, let us say they are two ranging rods are put there or two flags are there. So, they are basically indicating one straight line. Now, if we move along this straight line, what will happen? From the boat, one surveyor can observe that his location, ranging rod 1 and ranging rod 2, that is A2 and A1 are in straight line. So, he can ensure that he is moving in a straight line. Okay. At the same time, what happens is, we put a total station or theodolite at point B, and then we observe the angle of the boat at B, saying that the point A1 is a reference line as shown here. So, this is my reference line. Fine. So, now we are marking on this side also the same thing here technically. So, this is my outbound run, and now boat is moving. Okay. That is my first point. So, we have measured an angle alpha 1 here, and we have also measured the distance from A1 or maybe A2. Fine. Okay. Now, we are not stretching any float line, remember, right. So, basically what we are doing now, it is more interesting part, that how to measure the distance along this line, right. Because once we measure distance along this line, we can mark the position of the boat, because we are measuring two positions, one is angle alpha and one is distance along A1, A2 line. So, then boat will go to the next position, and again from this position to this next position, we are measuring the time. Okay. Let us say that we are having a clock, and using the clock we are measuring the time, and using, let us say, every 5 seconds or 10 seconds or maybe every 30th second we are measuring the sounding. So, this position is my sounding position, this is another sounding position, and they are at a regular time interval. Fine. That means my boat is moving at a constant speed, and that is the beauty of this method. That means I am measuring the distance with the help of time measurement and the speed of the boat, that is V into T, right. So, now we are measuring this distances from this point to this point and later. Fine. At the same time, I am measuring the angle alpha, and so by this distance measurement and angle measurement, I am fixing the position of the boat. I hope you can easily understand, this is very easy method. So, this angle is my alpha 2, and we will repeat this process. So, like this. So, we will also have some more, you see the time there is basically the measurement of the sounding. That means I am noting down here x, y, z, that is the x1, y1, z1, here x2, y2, z2, and x2, y2 is basically calculated will be later by this distances. So, basically we are measuring this distance here, this distance here, this distance here, and so on. And in order to measure these distances, we are using clock, that means speed of the boat into time difference. Fine. Okay, all right. So, now let us see this angle is alpha 3. Fine. We should take care always that the angle which is here called beta, let us call the beta 3, here angle is beta 2, and here angle is beta 1. So, my beta should always be more than 30. So, let us call beta I. So, any angle beta should be more than 30 degree, so as to create the good, or we say that well conditioned triangle. Fine. I hope you got the idea and you are able to recall the basic surveying concepts also now. Fine. So, this is my direct method 4, where I am observing one angle from the shore and distance from the boat. Okay. So, here I assume that the speed of the boat is fixed, that means there is no wind current, there is no water current. Again, these assumptions are valid here. So, now this is my inbound run here, and this was my outbound run here. Okay, so we repeat this process like this. Now, in this case, if we go back just in the previous slide, so these are the positions which are noted down by the angle observation and not these positions here. Okay, so now what we do, let us say we take every 10th reading for angle observation. So between these 10 readings, what will you do? The 9 readings are taken without the angle observation, but there we have observed the time interval and we are moving in a straight line, and that is why we know that we can always find out the angle with the help of theodolite by interpolation process. So this is the process, it is explained in the slide, you can read it yourself. Okay, so direct method 5. So we have seen a method in the previous slides that we are measuring some angle from point B. That means I am putting the total station or theodolite at point B and I am observing it. Okay, now understand that why can't I take the observations from the boat itself? Okay, that means I am not only measuring the time and the speed of the boat, okay, which is speed of the boat is constant. So I am only measuring the time. A surveyor who is in the boat is measuring the time. Fine. By measuring the time, and he is also now measuring the angle to point B. That means B is my kind of reference point. A1 is also a reference point. So there is a reference line between them. Fine. But now we are saying that we will stretch a line using A1, A2 because A1 and A2 they are in one line, right? And then we will move our boat like this, and then we will measure the time ticks in order to measure the distance from point A2 or maybe point A1. Okay. Now, in addition to that, we will measure the angle like this. So this is my alpha 1 angle. So I move to the next point now. So in the boat, again I have observed the distances with using the time ticks or the time interval I have observed, and again I will observe this angle alpha 2 here. Fine. Now we can see that we are measuring the alpha angles at certain interval, maybe 10th reading, every 10th reading we are observing. What about the intermittent reading? Intermittent readings are obtained with the help of, so for the intermittent readings, we are taking only the distance measurement using the time and assuming that the boat is moving with a constant speed. Okay. Now we can see here very clearly that once we do this kind of observation, in order to find out the angle values for the intermittent points, I will be using some kind of interpolation. So similarly, this is the last point to demonstrate. This is my alpha 3 angle here. Okay. Fine. So we should again be careful that my alpha I angle should always be more than 30 degree for the well conditioned triangles that are formed between point A1, B and the boat, right. So I hope that you can understand the difference of the method 4 and method 5. In case of method 4, we have one person over B and one person and one surveyor in the boat. That means there were 2 persons coordinating among each other. Now we don't have that problem. The surveyor is in the boat, the whole survey team is in the boat, and we have marked point A1 and B1 and A2. Now using our own sextant instrument, we are measuring the angles alpha 1, alpha 2 and alpha 3 at regular interval, let us say every 10th reading. And intermittent readings are measured, or the distances are measured between the 2 points, let us say this point and this point. So all these readings are measured with the help of time interval or the watch. Fine. I think you can now understand that better control form of survey is this, and references are used for checking. Fine. The sextant is used and the angle again alpha should be more than 30 degree. Now let us look into the other possibilities. Another possibility is the resection and intersection. What is resection and intersection? I just repeat it for you, or we can recall it. Remember, there is a point which is an unknown point that I want to establish as a control point, and hence here we have A, that is control point, B, there is another control point, and C, there is another control point. So now from this point I want to find out, let us say, x and y. So I can measure this distances, okay, and these angles also, fine. So by these 5 measurements I can find out the position xy, and this process is called resection. That means I am determining the unknown control point right by observing from the unknown control point to the known control point. So my ABC are known control point. On the other hand, if I say, let us say there is point A which is my known control point, and B there is another known control point, and there is unknown point D. This one is my unknown control point. Okay, so what if I put the total station or my theodolite over here, and then I observe this distances from here and from here. Moreover, this distance is known to me because we know what is my XA, YA and what is my XB, YB. Fine. So this distance is, let us say, DAB is known to me, and also we observe this angle alpha and beta. So now I can fix this point, fine, and I can find out the coordinate of xy, coordinate of unknown point as xy. So this process is called intersection. So in intersection we have observations from A and B known control points, and in case of resection I have observations from the unknown control point here. So now we are using the same methods for the purpose of hydrographic surveys also. So here my unknown point is the point where we are taking the sounding, or it is a boat position. However, what are my known points? The points which are in the shore, which are permanent in nature, or which are control points on the shore or on the coast. So let us look into the intersection method here. So we see here that point A and point B are my known control points from where I am measuring the position of the boat, that is my B here. So it is my boat position at a given instant, right? Okay. So this distance D is known from the map or maybe from the field itself. Okay. Then what will I do? I will measure this angle alpha and angle beta for the current position of the boat. So there is a person in the boat who will raise the flag, and on the flag we will take the observations from position A and position B, or control point A and control point B. So we have measured angle alpha and beta. Since we know the distance D, I can find out the coordinate of point P by x and y, and x and y given by this formula, by these formulas. Okay. Now you can see here that how accurate this method is, because there is no control, or we have the very high control at point A and point B, because we are using some instrument like theodolite or total station, and we are measuring the angle which are not affected by any vibration of the boat, or which are completely independent. Moreover, we also measure the angle theta here at the boat, and remember that theta is measured to ensure that triangles A, B and P is well conditioned triangle. Fine. Okay. Later on, if we find that theta is less than 30 degree, we will reject that particular observation. So you got the idea now? Fine. So here we can see that instruments are used in place of references on ground surface, and then even if there is strong current is there, in that case what will happen? Boat will maintain for few seconds or few minutes in certain position, right? That boat can perform this action for few seconds or few minutes. Now during that time, as I told, that a person surveyor who is in the boat, he will raise the flag, and using that flag position we will be measuring the angle alpha and beta, right? So we will the instrument at point A and B, they will be targeting that reference flag which is raised by the surveyor who is in the boat. Okay. So it is very laborious and expensive as well as, but it is at the same time it is very accurate also. So when accuracies are very high, or the demand of accuracy is very high, or at the same time if the wind currents are very high or the water currents are very high, in that case we should use this intersection method. Now look into the resection method. Okay. In case of resection, what happens is we are at point P in the boat in the water, and from point P there is one surveyor T, and that is observing the distance angle alpha and beta to the permanent marks C and A. Okay. What does it mean? I know the coordinate of A and C in the map, and they are on the shoreline, they are permanent in nature. So, I am making this point B as my reference point, and around that point B I am measuring two angles alpha and beta by sighting A and C from the boat, and so I am using the sextant here. Fine. So, this method is my resection method. Okay. As we know, the distance between A and B as well as distance between A and B and C, all distances are known. I can find out the position of P at a given instant where we observe. And so, this method is equally intelligent and diligent method. At the same time, it is accurate also. Moreover, since these are only the permanent reference marks, so the complete survey team is in the boat. So, we do not need much of the survey team, or the small team of surveyors will also be good. So, this method is little more independent than intersection method, or it is less laborious. So, chances of mistakes are minimal here. Secondly, we should be careful enough here that the angle alpha plus beta should be more than 30 degree for the condition of well conditioned triangle. Here, when even the points are isolated, that means these points, this point, this point, this point are to be observed. So, let us say it is P1. So, we have P2, P3, P4, and I need to perform some observations on all these points. Resection method is one of the good method, like intersection method. Fine. Now, let us make the combination of resection method and intersection method. In this case, what happens here, that there is a point P here where the boat is located. Okay, and now here at point A and point B is there. Point P is a kind of reference mark. Fine. So, at point A we are establishing, or we are setting up our instrument, say total station or theodolite, and then we measure the angle at A to the boat for the current given position of the boat, and we also know the distance D. So, using distance D and the angle alpha and angle beta which is measured at the boat, we can determine the position of boat P, that is my xy location. Again, this method is equally good like resection and intersection method, and it is combination of resection and intersection. Fine. By using the same formula, you can find out x and y, what we have used in the intersection. Now, locations by intersecting ranges. What does it mean here? You see, along the shoreline, if you put a point like this, fine. Now, what we'll do, we'll put a flag on first point here, and then we'll put another flag here, and then we will move our boat in certain direction. So, I know what is this angle. Okay. So, let us say I have observed this point here. Okay, how to observe this point? So, since there is a flag here, as soon as the boat which is moving along this direction, it comes in this direction, it will stop and observe the x and y position here. Okay. Now, you got the idea. Since this angle is fixed here, so I can always find out what is this position x and y. So, I will repeat this process. Let us say this is a flag and boat is moving parallel to the last previous line, and so we determine these 2 points also. Okay. So, this is the next flag and we move parallel to this and we determine these points, and so now we are getting the points at a regular interval or in a regular grid fashion. So, let us keep on doing this thing like this, and so on. So, this method is called locations by intersecting ranges. So, observations are taken periodically at a point or an area. The silting and scouring are checked with respect to the, okay, now let us say this method is creating a regular grid, and what I want to do here, I want to check whether is there any silting or scouring. Okay. For that purpose, I need to check the whole area in a very regular grid fashion or in a regular format, and for that purpose this method is useful. Fine. I hope that you are getting into the hydrographic survey now. So basically for the reservoirs where wind currents or harbors which are very near to the port, right, where we expect there should not be any scouring, we generally follow this method in order to ensure that if there any scouring or silting has happened, because that is going to affect the available draft of water at certain period or at a certain point of time. So now we have measured, let's say, all these points. Let us look into the tachyometric observations and how do we use the tachyometric observation in order to find out the position. And remember one thing, that now we have already said that as and when we observe the position xy on a water surface, we will always observe the depth. So sometimes even if we say that let us take some observation, so it means that we are taking the sounding also, right? Okay, so let us look into the tachyometric observations where we are using the logic of tachyometer. Okay, you might have used tachyometer for your basic surveying, where we say the distance d is given by ks plus c, where s is my staff intercept. So we are going to use the same logic here. Fine. So let us see, this is my tachyometer put on point B here, and now this is the boat having an staff as shown in the figure. Okay. So now this is my staff intercept here, S. Fine. So this is my sounding observation. Okay. So this is the depth d here. Okay. So this is the distance d. So this is my location of the point. Okay. Now what happens is, as we move the boat, okay. So this is the formula I use. You remember, d is equal to k s plus c, where this is my s, this is my k here and c here. For the calibrated instrument, we know that k equal to 100 and c is equal to 0 is always taken, right? C and k values are decided after the calibration. So in general, these are the values we take. Okay. So now what will we do next? Let us move the boat like this, and in this position again I will measure the staff intercept, which is increased now, and so my depth of the sounding is all okay. So I can find out the distance. So now I can find out the next distance, let us say the distance again for this position, and at this position also we will observe the sounding measurement like this. Fine. So this is the distance d here, which again I will calculate by this formula. So now you can see, in this case we can perform the sounding or by observing xy position by the distance using tachyometer and the sounding by the sounding instrument. So now we are preparing some kind of section data here, right? So this method is called tachyometric observation method. Okay. Now this is not suitable when soundings are to be taken far the offshore. Again, it's usable only when we want our survey to be performed very near to the shore or near to the point which is very close to the shoreline. So now the next method is electronic positioning system. What is electronic positioning system? So far we have talked about positioning like GPS, global positioning system, but what is electronic positioning system? Well, before the GPS, there were many systems in place which are based on radio detection or microwave detection. So electronic positioning system is basically microwave ranging system, right, which uses the logic of triangulation by theodolites. Okay. So basically it replaces the triangulation method by distance measurement, or what we call the trilateration. So we measure range and range positioning technique. Okay. So generally, so this method is now superseded by global positioning system, or what we call is GPS. So now we are using the differential GPS. Because of the differential GPS, what happens is I'll come to know the exact position x and y of my vessel or the boat. While so there is a GPS mounted in the boat, and that is my rover, and there is a base station we have established on the shoreline anywhere. Fine. Generally we take a permanent station so that if we repeat the survey, we can come to know what are the changes that happen over the time in some of the positions in the sea. That means, let us say if I try to observe that there is some kind of hazard like tsunami or there was some kind of earthquake. So what are the changes that happened in the sea or the seabed in that case, if I use a permanent station, right, that will be more useful for us. Moreover, if I want to do some kind of change detection, that means over the period of time, what is happening? Maybe a point, it is subjected to a lot of currents within the sea, and so it is being silted again and again for some reason. So if we take a permanent base station or a station which is permanent in nature, and we establish our base again and again on that point, what will happen? Every time I will measure my vectors which are from the same base station or the same reference position, and that will give me more confidence while locating some of the obstructions. So anyhow, DGPS method is the current state of the art technology and which has superseded all other methods. So if DGPS is available to you, it's always necessary to use, or it's always advisable to use. Moreover, I would like to say one thing here, that GPS is going to measure the position only, x and y. Again, but we need to measure the depth of the water by the sounding only. Well, that is very clear to us. Okay. Moreover, here I would like to tell, because of the small vibrations in the boat, what will happen? We need to put some kind of tilt correction with the GPS, and that is the must thing here with the GPS, because GPS is going to give me very highly accurate XY position. Okay, but these positions should not be made wrong because of the vibrations of the boat, that will create some kind of corrections, and so we need to have a tilt sensor. If you read the specifications of the DGPS these days, most of the DGPS which are high end, generally more than 500 channels, they are coming with the tilt sensor for the tilt correction, and these can be used even for the hydrographic surveys. But always consult this aspect with your manufacturer of the DGPS instrument, whether can this instrument is sensitive enough to use for the hydrographic survey, so that we can apply the tilt correction. Be careful on this part. Now, so far we have finished our horizontal positioning survey. That means we have located our XY. Now we have said every time that we are measuring the soundings, the depth, vertical depth at each and every point on the water surface wherever we have measured x and y. Now what about the vertical control? How can we establish the vertical control? First of all, we take and permanent reference mark, and there we use the bench, which we use as a benchmark, okay, which is available on the shoreline or coast. Now using that, we are trying to connect our sounding instrument observations so that we can determine the sea surface or the water body surface in a certain vertical reference frame. I hope you got the idea, and that is why we call it vertical control establishment. Fine. So it is very useful for the route surveys, construction surveys, and topographic surveys. So we establish the number of benchmarks depending upon the requirement of the project. It is always in conjunction with the horizontal survey. We do not separate here the horizontal and vertical survey, right? So now, as we have already seen how to use the lead sounding line, and we also use the echo sounders for the depth measurement, and then we also use the advanced engineering echo sounder, that means automated system, sometimes less automated systems. But echo sounders more or less these days are completely automated, or we say that we need the minimum human intervention for the echo sounders. But at the same time, we can also use lead line, or we can also use the sounding pole. Well, sounding pole has a limitation of 5 to 8 meter length, so that's why it is somehow preferred only for small depths of level of 5 meter or maybe 6 meter. But the moment we go for higher depths, we should go for lead line, or if we can afford, we should go for the echo sounder. So that is my vertical control for the hydrographic survey. Fine. So here, let us look into the applications. Applications means, let us say we have acquired the data. Okay, let me tell you one thing, since echo sounder itself is a big area, so we are going to consider them in the next lecture, but here we assume that we have observed x, y and z positions. Now with this observation, what can we do? We can have some applications. First is, we want to find out the capacity of the reservoirs and lakes, and that is the most important application. So first we look into those applications. So there are two methods, one is contour method and another is cross section method. Okay. In case of contour method, again we have two methods, end area method and prismoidal method, and here also we have same two methods. So, let us look into these two methods and then we will go for the next lecture. Okay. So, contour method is very reliable method because it gives you reliable results. So, what we do, okay, instead of reading the slide for you, you can read it yourself, but I will explain the method. So, that is my end area method. So, what do we do basically? We take some map here, fine, and now we draw a section here which is required, where we require to measure the flow or maybe velocity of the water. Now, what do? We develop a section by projecting these lines, and now we got this section here as shown here by this line, fine. This complete section is there, okay, fine. Then what we'll do, we will divide this whole section into equal interval of the contours, let us say h, h and so on. Okay, let us say on the map we measure this A1 area using planimeter. Similarly, I measure A2 area at this level and so on, fine. Or we measure this level A1, A2, A3 from our hydrographic survey. That means we have derived this section from the hydrographic survey. Now, we have divided this section into different levels, and at each level I am determining the area, which is planimetric area A1, A2 and so on. Now, by using the simple mathematics, I can write the volume between section 1 and 2. So, I can say here, so that area, average of the area into height, that is my volume of the water. Similarly, I can write for each section, for this section like this and so on. I will repeat this process, and finally, I will add all the values here, and so we got this formula. And now, if you make it total here, this formula will come, and there we write that first area and nth area plus 2 times all the middle areas into 0.5 times h. H is my, let us say, contour interval or the vertical interval of this method. Fine, that is my end area method. Let us come to the contour method, where we are going to discuss the prismoidal method. Here you can see the formula L by 6, A first area, A end area and the middle area 4 times. So, this standard formula for the prismoidal method, where L is nothing but the distance, and the distance between the two sections A1 and A2 and so on. So, now the distance is h. So, we are dividing h into two parts, h by 2 and h by 2. And now we are saying that L is equal to my 2h, fine. Okay. What does it mean? It means that I am considering 3 sections at a time, the middle section at middle, one is first section, middle section and the end section. Okay. The distance between the first and the middle section is h, and the distance between middle and the end section is also h, and that is why the length between the first and the third section or first and the end section is 2h. So, L is my 2h here, fine. So, now I use this formula, and there I put L equal to 2h here, and then let us say there are 3 areas, for example, A1 here, then A1, A2, A3. So, I put A1 plus 4A2 plus A3 by this formula here, fine, and then 2h by 6. Similarly, when I consider 3, 4 and 5 section, that means this one and this one. So, this is my h, this is my also h here, fine. So, basically this is the h interval, or what we call is contour interval, fine. Okay. So, again I am using this 2h by 6 here, and then A3 plus 4 A4 and A5. So, here A4 is nothing but my middle area, fine. Now, since we have covered all the areas from A1 to A5 in 2 calculations, so the total volume is given by V13 plus V35, and so if we do it, the summation, I will get finally this formula, that is A1, and it is the nth area. Okay, now we have shown you the total formula. Now imagine that instead of 5 areas, we have total number of n areas, A1, A2, A3 and up to An. So what we will do? We will take the contour interval h, fine, and then these areas are separated by the contour interval, okay, on the section area. Now you can imagine that I will take A1, that is my first area, the An is the last area, and in between area I will divide into the odd areas and even areas. So A2, A4, A6, they are my even areas, A3, A5, A7, and so on, they are my odd areas. Then I will use this formula straight away, right. So, that is my prismoidal method. So, the cross section method it has the moderate degree of precision, and so the contour method is very much reliable here. Okay. We can see here that traverse is run and desired topography of the shore are obtained using a stadia, that means tachymetry. Area enclosed obtained by planimeter, that means on a map if I have the area, overall area, right. So, what will I do? I will do the map and then I will draw the sections. At different sections, what will I do? I will take the planimeter and make the area of the particular section, that is horizontal section, at a certain elevation level. Fine. That volume between the bottom part and the deepest part is neglected here. Fine. Be careful. So, total volume is nothing but after neglecting the first and the last. So, we have the partial volumes here. Fine. So, we make the summation of the partial volumes and that is my total volume, but this method is much accurate here. Okay, next method is my cross section method. In cross section method, it is moderate degree of precision is obtained. So, area is basically divided into approximate triangles and trapezoids. Fine. The boundaries are sections where the soundings are obtained. Okay. So, I have calculated my sounding positions, right, and so I have prepared the sections here. So, now you can read it yourself. So, instead of reading slide for you, I am going to explain you what is my method. In cross section method, again we have the prismoidal method. Well, so here we are saying that again this arrangement of the sections are same. Okay. So, let us see, this is my H1 section which I measured in the field, this is my H2 section which is nothing but a distance between A2 and A3 here, fine, and this is my AM here. AM means the middle area that I determined between A2 and A3 by some intersection scheme. Okay. Intersection could be, let us say, the average, or intersection could be some different value. That means it depends on your interpolation scheme. So, let us say I have, with respect to my middle area, I have some first area as well as end area. That means the cross section area of the two sections which are adjacent to the middle area I have observed. Okay. So, basically I observe A1, A2 and so on. Then we calculate the middle areas, the middle cross section areas by interpolation scheme. So, let us say we have complete data now with us. Fine. So, you can see here this is my H1, and if I divide by H1 by 2, H1 by 2, now I want to use the prismoidal method. Okay. So, let us say if I write, remember we wrote one formula L by 6 where L was equal to 2 times H. Here you can see the 2 times H is nothing but, I can see here that H1 itself is equal to 2H. Why? Because I am using one A1, okay, then I am using A2, okay, and then I am estimating the middle area between these two sections, A1 and A2, and that is why my H1 is divided into two parts, H1 by 2 and H1 by 2. So, basically H1 is equal to L, fine. So, now we estimate the middle area between A1 and A2 and we put it here. Similarly, for A2 and A3, we put it here, that, and this AM is nothing but, in this term it is the middle area or the intersection area obtained by the intersection of A2 and A3, fine. And similarly, I repeat this process. Here I am putting H1, the distance between the A1 and A2, here I am putting H2, the distance between the A2 and A3, and so on. You can see all this thing, and finally after doing this calculation we make the summation here in this formula, and this is my prismoidal method here. So, let us demonstrate the end area method here. So, let us say this is my water body, and so this is my area A1 which is on the left hand side of the water body. This is my cross section area. So, this distance is H1 from some reference point, and then this is my area A2, this is distance H2, and again this is my area A3 and so on. So, now I am showing you all this, fine. So, now finally I have A7 area which is at the end here, something like this, some kind of area, and similarly A1 is also there. Okay. So, what are my formulas now? So, these are my formulas again by end area method. That means I take the average of the two areas, let us say A1 and A2, fine, and then I will multiply by this height H1 or this distance H1. Similarly, I will repeat the whole process and finally I get the total volume of the water by summation. This is my end area method for the cross section method. So, now we have taken some of the images from some sources like Wikipedia, and so we finished our lecture 2, and in the third lecture we will look into the operations of the echo sounder for the sounding measurement or the vertical depth measurement of the water surface or the depth of the seabed. So, thank you very much.